Well, building the racking system here. Got the piers installed for this ground mount. Yeah, it's pretty close to online. So when the system gets done, the cross pieces will go here, 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 here. And then the rails will go there. And I got these big 630 watt modules. So it'll be one panel, 1, 2, 3, 4, all the way down. There'll be 2 strings of 6, making a total of 12. I try not to overthink these projects. Lumber is reasonably cheap. I think I spent a total at Menards, maybe up to $1,500 for all the material, bolts, boards, pretty much everything. So yesterday I set the rear piers, and then after that kind of sets, then I set the front piers. And the tolerance on the second pier doesn't need to be as accurate as that one. I try to get that one to line up absolutely flawlessly, but if the tolerance of the string is within like an inch this way or that way, it's fine, because the only thing that really matters is you want these to line up. These need to line up perfectly. But when it comes to this axis, not really. It can go this way or that way a little bit. You don't want to go too much, but it's just mainly lining these up, these 2 piers together, these 2 piers together, these 2 piers, and so on. And you want them spaced reasonably equal apart, but that doesn't even need to be perfect either. There's some tolerance there, you know, and but yeah, generally you want this to be perfect. You want the back one to be as close to perfect as you can. The tolerance on the front ones could be off. So, but I'll keep posting videos on this, but I'm gonna let the concrete set for a few days. But it's pretty much, yeah, you get the second pier, your first pier done, second pier should set. And the cool thing is, when I put the cross pieces in, that's when I'll cut off the nubs. But I'll document that, so follow my channel if you care to see this this array being put in. I'm putting on the wooden rails. So I just sister 2x4s. You need clamps because the top one, you know, they always bow. I use all Deckmate coated screws. I don't just really basic and simple. See how it looks. That's why you need clamps. The first rails, can't see it, but there's 3 screws in this one and 3 in this one. And then after everything's put together, I put lags, recessed lags, bang, bang into that. These get cut off, and then I drill a hole through that and I put a lag, just standard galvanized lag, and 4 screws. I know people want to say maybe you need to notch that. I'm not against that, but this is only holding up a pane of glass, so it's not like a deck. If it was a deck and people stood on it, Oh yeah, I would use a 2x6 and use a saw and notch the saw. So then this weight of this board went onto that. But this is for solar, guys. It doesn't need to be, you need to, true artist knows when to stop. These panels are so big, there's gonna be 3 of these rails. Because I wanna make sure there's 1, 2, 3 points of connection per panel, and there's gonna be a total of 12. These panels are enormous. I'll probably never get panels this size ever again, but it's getting really hot. I might put this rail on and, you know, kind of find my mojo, and next video clip will be more done. Cue the montage. Yeah. So I'm setting the first module now, and this one's the biggest pain in the butt. I usually use those 2 end clamps. Since I'm doing this by myself, you got to be very particular, but got my center point marked right here. And the trick is you spend more time getting this first module set. You know, make it so that it's got the right here, make sure it's reasonably centered. Cool thing is all I gotta do is center that line with this board and take the mid clamps and make sure the mid clamps are centered there. So I got these really basic end clamp, mid clamps. You can see, you do, oh, forgot to put the washer in. Yeah. But it goes lock washer, and then this, I guess you can call it a nut, but that's it goes into the groove. That's the these are the end clamps. So the panel is right where my middle finger is. That's where it goes. And then these are the mid clamps. Pretty simple to use these bolts, and it just bites down. Now, thing you have to remember, I do at least 2. If I can, I'll do every single one. Actually, technically should do every single one, but I am a bit more lazy, and I like skipping steps if I can. But this is a bonding washer. Company known as Weeb invented this technique. See the serrations here and right here. What it does is when you bite down on the panel, you put this between the panel and the rails, and when it bites in, it actually bites into the metal. It breaks the little film coating that the aluminum generates, and it physically bonds the panel to the rails. And then when you put all the panels in and you have all these different points of grounding, it does what I like to call hyper interlock grounding. So the beautiful thing about doing it like this is that you really only need to have one connection. So the disconnection is going to be over here. So I can actually just run the ground wire out of it and bond to the first module, and it'll bond all the modules there. But of course, I like to double up my bonds in case this whole panel was taken out of the circuit and there's 2 strings, I like to put a bond per string. So I'll run a ground wire, bond it there, and then I'll run a ground wire along that rail here. And at the midpoint, I'll ground this panel so that grounds that. Even though all of them are grounded as one, I put the second one as for redundancy. So in case like I took this module completely out, it doesn't unground everything downstream. But bonding is very important. If you don't, static generates, because charge controllers send like pulse, kind of like AC waveform type stuff. And I'm not going to proclaim I'm the utmost expert on that side of the system, but yeah, you can see though that these modules big. It's 630 watts. This thing's freaking huge, man. Anybody considering getting panels this big, keep in mind shipping these is a nightmare. I was able to get a good deal from Watts 24/7. I kind of feel like I did them dirty on the shipping, but I don't know. I'm gonna throw Watts more business, because he worked with me on getting the stuff here. But the guy from FedEx that dropped my entire pallet off, I can tell hated my guts. Just gave me attitude the entire time, and can't really blame him. But I'll yeah. So, but I'm not gonna film me putting the panels in, because I'm here by myself and I don't have time to film as well as set modules. So okay, now you can see I got the rail centered, the first clamp. Since like I said, I'm going to be moving this one around when I do this string, I'm not going to bother putting the grounding washer yet. But when I start on the string, this is the one I'll start with. I'll put the ground washer in, and start my run. Over here, you can see it's landed pretty much where it needs to land. See how it's about even to the right and left. And this is where I'll start doing my string. And yep, gonna bond all of them, and should look pretty good. This is what the panels look like. Will look like underneath. Pretty sweet. Hopefully, if there's snow on the ground, this is the Midwest, it'll and I'm gonna put stone underneath all this, so because for reasons you can see where the mower goes. Now I know where the mower cuts. I know how far I can put my rock over, so then he can mow right over it. You don't even need to use a weed whacker. I'll put stone around there, and I'll pour a little bit of concrete at each base so grasses don't grow up at each pier. So I don't want grass or weeds to ever grow underneath this thing, because I want it to look really good every single day, low maintenance. So good. First string is done. I had to move some of the mini rails and remeasure them. Yeah, you live, you learn, but worked out. Some of them are a little bit off to one side or another, but as long as they bite down and clamp, it's pretty good. So Well, looks like it's working fine. Seen about 3,000 to 3,200 watts per string at about around 275 volts, which is about what the math says it should be. Charging the battery at about 6,000 watts. Basically, currently the battery's at 94%. I want to see it fully charge and ramp down before I start flipping switches in this. This here is the main grid panel. This is the critical loads panel. Anything in this will run off of the inverter. Anything left in this only is on the grid. The certain loads I left on here is the air conditioner and the stove. And the thing is I didn't want, you might hear the sound of the oxygen machine upstairs, but I didn't feel the need to waste power on, like basically like on just cooking some rice. The air conditioner was an option I gave to her. I was like, what do you, she wanted a little bit more energy security, and so what I did is I put in a little transfer switch for her air conditioner. So if it's like a heat wave out, the battery's near full, and it's sunny out, and plus there's a backup generator on the system. Right now it's on grid mode, but I can switch it off, or I can transfer it out of there. And on this inverter, there's a smart load, and the smart load can cut loose that circuit in case the battery got down to a certain amount. So you can run the air conditioner as long as the battery's over a certain voltage. And so I made this the 100 amp panel breaker, and that feeds this distribution box here. And the center breaker goes to the inverter. This SPD breaker goes to this SPD, and the bypass goes to this breaker. Now right now her house is in bypass mode, and I have the main principal, which goes to the inverter. So I have it right now in bypass, and I put these simple little things in for a transfer switch. It's like a really lazy homeboy way of making one of these. I actually would rather use something like that, but these are all of our house loads, and they're mapped to there. So I just literally put numbers on there and mapped them to there. Make it simple. But this basically is going to run our whole house. And it should do it quite nicely. And actually, if it wasn't for the fact she had life support equipment up here, I probably would have put the stove and the air conditioner on this. I still would have probably put those on the smart load output, the air conditioner, and left the stove on this one. But other than those little differences, but the idea is that if you use the stove for a couple minutes every day to cook some ramen, it might only cost you a couple cents in electricity from the utility. And she's like, yeah, during an outage I can live without my stove. She still have microwaves and things like that in this system, but it should be fine. Let me see if we can. You can see the panel. The grid's at zero. It's seeing the grid power. It's 0 watts because it's in full off grid mode. Right now, yeah, you can see it charging at a full rate. You can see everything is moving. So, all in all, it's looking pretty good. I'm gonna wait. I want to see the system tied in and see if any issues happen before I start. Before I do this interlock and switch it to the inverter. But for now, she's running off the grid right now. To anybody out there that just wants to have an inverter as a backup, that's the way you would do it in your panel. You add one of these in and you can interlock it. So you can never have this breaker and that breaker on at the same time, because that would be bad. The one thing I don't like about this is that if you have a non-electrician see this, they might screw up and have this cover off, because if the cover's off, you can flip both breakers on at the same time. But of course, I doubt anybody's going to open this thing up that's not a qualified electrician. So, but I like how the system turned out. There's surge arresters up the ass on this thing. This thing has built-in SPDs, which was nice. I didn't need to buy extras, which complicates the wiring out at the array. Makes it simple, but I got these 300 volt midnight solar AC SPDs. One on this panel that protects power flowing into the inverter and all the equipment downstream, including it'll even supplementarily protect anything in this. And then you can see this one protects this panel. So any power coming out of the inverter to that panel is protected by that SPD. So yeah, this is what I've been working on for the past few weeks. But it's not a bad little system, I have to say. They're getting closer to the perfect inverter. I mean, they're getting pretty darn close. This may be a high frequency inverter. There's not galvanic isolation, I believe that's what it is. There's no transformers inside of this. Not like a Schneider or any of those other types of pieces of equipment. But this unit does 12,000 watts and is only $2,500 roughly out the door, at least as it stands right now. Who knows what it'll be because of reasons. Now look, it ramped down wattage because it's coming up to a near full state of charge, so it's exactly what I wanted to see. So everything's working well. But for the price, this inverter is pretty nice. Well, one little thing that's kind of neat too, you can AC couple this inverter, and there's even timers in this thing, so you can tell it to charge. I think it's up to 3 timers on it. So you can kind of say, only buy power from the grid to charge the battery at these times. So you could be like, if the power is expensive during the daytime, you can turn those circuits on, and then you can basically only charge at night. And then you can, if you're going to charge the battery with AC power, don't do it in the day when the power is twice the price. And that's kind of a neat feature. And the smart load, instead of running it the way I've got the configuration here, as running as a smart load, apparently you can hook a grid tie inverter up to this smart load and AC couple the system. So the internal chargers in this could actually charge the battery off of a grid tied system. It tricks those grid tie inverters thinking the grid's there. I have not messed with that on this inverter. I messed with the other inverters like Outback and other brands like that, but not this, but they're all basically the same. And I believe how this works is the relay that controls the smart load will open up when the battery is at a certain state of charge. So it's basically like it cuts off, it literally disconnects the grid tie inverter onto this. So then you can have the best of both worlds. You can have, if you have an existing grid tied system, you can put this inverter in and add battery as well as more solar into your system. But of course, the one caveat to these off-grid inverters is you need to build a backup panel. You have to have a critical loads panel. So if you're an off-gridder, you don't have this panel. This panel won't exist. This is your main service box. But in the case of this system, there's a subcritical panel. This is the critical panel. This is the main utility panel. Here's my system.